All right, I hope this works. As promised, here is a video that goes through this following problem here that we did not get to in class, yet other sections of AP Stat did. Mr. Fitzgerald coming to you from home. Here we're asked to do a regression hypothesis test, and then a subsequent confidence interval given this data here to see if there's linear association between math and verbal SAT scores. First thing I should do is enter this into the calculator. So let me go ahead and do that. Let's see, will this work? Yeah. All right. Maybe I should, whoops. Maybe I should have done that before I started recording. Okay. So it says run a slope test to see if there is a linear relationship between verbal SAT scores and math SAT scores for your school. If there is, then use a 90% confidence interval to estimate that slope. It says assume the conditions have been met. I'm going to go through those anyway. But here's what the hypothesis test might look like. At home, so I haven't done this. Please work. Okay. Let me scroll a little bit. Oh, can't scroll. Our null would be that beta 1 is equal to 0, which means no linear association. Man, this trackpad is not very fun, this drawing pad. Then we would have the alternative hypothesis of saying that this slope beta 1 is not equal to 0, which means that there exists, that's the math word for exists, some linear association. Some linear association. We're going to want to name our test as well. Maybe I should have done that first. It's either called a, let me just zoom a little bit. You guys still see that? Need to make this smaller. It is either called a linear regression. Oh, this is better. Linear regression t-test, or a t-test for slope. Either of those works just fine. Since we're not given the level by which we would do this hypothesis test, we would assume alpha is equal to 0.05. But when I see a 90% confidence interval here, that might suggest that you could use alpha of 0.10. Doesn't make it clear though, so I'm just going to go with my alpha of 0.05. It's also important to define your degrees of freedom, which is n minus 2. There are, I think, roll please. There are 10 points, so that our degrees of freedom is equal to 10 minus 2, which is equal to 8. Let's go over our conditions. Even though it says assume the conditions are met, I want to really make sure that we get these because it's really important that you know how to do that using the calculator on the AP exam. Let me just erase all this so I can more easily write. Or will that, if I just do this, will it erase? Oh, yeah, there we go. Let me just go a little bit up more. Conditions. One is the independence condition. And since we see here that we have 10 randomly selected students, a simple random sample checks that box. What we can do, if that's not the case, is like, we must say, like, we must assume that these, or we can reasonably assume that, one's math and verbal scores don't influence another's verbal and math scores. The second condition is linear enough. So for that, we're going to need to make a scatter plot. Whoops. With that here, since I have my data into L1 and L2, we go to make a scatter plot, which is by going to second stat plot there. Turn your plot on. Make sure you have this guy here highlighted, that's scatter plot, and just your L1 and L2 and your X and Y. Then you do zoom 9 to get there. And that looks pretty darn linear to me. You're going to have to say that. Like scatter plot appears linear. I'll say appears quite linear. The third one is the residual plot. In a residual plot, you want to see no discernible pattern, or like no apparent pattern. So let's take a look at that, and let's make sure we know how to do this, because there might be an error that comes across for this. So, and I think this might happen here since I haven't done this yet. So here, I'm going to the same plot, and I want to make this L2 my residuals. So let's go there. To get to residuals, you're going here to list. So I have to do second stat. And see, it's actually not there. So there's a couple things that we have to do. So I'm going to be jumping ahead a little bit, because you might know that in stat over to test at the bottom for a linear regression T test, if I do that, I'll tell you now, like here, now you see residuals show up. That's because before I did this, the calculator didn't have a reference or like anything stored in memory for what the predicted line of best fit is. So either by going to the calculator to run the test, or if you were to just calculate the linear regression, the line of best fit here, just by doing that, you'll get the residuals will now show up in that list there. So you got to make sure you do that. Otherwise, like you might see people have come across errors like when they try to go to zoom 9. So just make sure that this is done, like you have this reference, so the calculator knows how to compare it, how to calculate residuals. So now if I go here, I can just make that residuals, and I go to zoom 9 now. And while I see some like unequal variation, like in like these residual heights, there's not a clear residual pattern. There's gray areas for this. You can say, well, there's not quite a clear pattern. Yeah, then you're good to go. So you got to make sure you say that. No clear residual pattern. Or pattern in residual plot. And then 4 is that the residual histogram is approximately symmetric or normal. Let's use the term symmetric, or by that I mean bell shape. So let's do that. There's actually two ways you can do that. One of them is going back to your stat plot. I want to make this histogram of the residuals. So I'm going to highlight that guy and just make sure this guy here is residuals, which again is second stat, all the way at the bottom. Let's take a look at that. That might be a bit troublesome to see, right? It's like, is that symmetrical enough? There's definitely a gray area there. So if something like this happens where you're not entirely sure, well, we do see like a rough bell shape, even though it's skewed. Also, that we have these really big bin side, like bin width, so it's hard to tell. If you had something that was troubling like this, and you couldn't quite ascertain that, the other thing you can do is do the normal probability plot of the residuals, which is this guy right here. And remember, for the normal probability plot, you see how close are those points to a straight line. So do that, go to zoom 9, and that looks pretty darn good to me. So you can either say that the residual histogram is roughly symmetric, or residual normal probability plot is roughly linear. Either of those works. Those are our 4 conditions. From here, we can just go to our calculator linear regression t-test, which I did a minute ago, but let's use that. Make sure you had the stuff from before where I had like the degrees of freedom and alpha level. So go to stat, over to test, all the way near the bottom. For this, make sure you're just using your raw data L1 and L2, and also make sure that this condition here, or like type of test, is always not equal to. So from this, looks like we get a t statistic, a test statistic of 6.84. Which gives a p-value of 1.3 times 10 to the negative 4. So isn't that... The negative 4 means 3 decimal places, 0.0001. So in this case, it actually wouldn't have mattered if alpha was 0.05 or 0.10. So, wouldn't we conclude by saying since our p-value is less than alpha, we reject that, how? We reject the null. This means, and this is wacky, we have convincing evidence that there is some linear relationship between a student's math SAT score and verbal SAT score. I'll say math and verbal SAT scores. So that's that. That's the hypothesis test for this, the linear regression t-test. Now that we have concluded that there is linear association, we want to see, okay, what is that linear association? Let's make an inference of what that slope actually is. So from there, we can make a confidence interval, which would be a linear regression t interval. We are told to do it at the 90% level. it says up there. So let's do that here. It's actually in the very similar spot. That over to test at the bottom here. It's just the next one to it, linear regression T interval. L1 and L2, just use the raw data. Make sure your confidence level is accurate as 0.90. So there is our slope here. Let's just do 0.836 and 1.461. Whoops, 1.461. I already forgot it. Yes. So then here we need to conclude. So can I say we are 90% confident? Wait, what happened here? What happened there? I don't know. Oh, this is supposed to say 90% level. Yeah, I don't know what happened there. We are 90% confident that the slope of the true regression line whoa, what happened there? This is why are things disappear? Things are disappearing. Regression line where x equals, I don't know what's happening, where x equals, is x our math? Please. Yeah, where x equals math score. Math score, SAT score. And y equals verbal SAT score. Oh my goodness. Is between 0.836 and 1.461. What the heck is going on here? Wow. Yeah, so we are 90% that we want to conclude by saying, like, well, we're 90% confident that the slope of the true regression line that connects these two variables is between these two numbers. I don't know what happened with this computer here, with this program. Either way, I hope that helps. See you all on Monday.